Hello. So in the last couple of videos we've been talking about certain forms of finding derivatives, such as the power rule, the chain rule, the product rule, and the quotient rule. Now here's a new method that's a little bit different. It's called implicit differentiation. And let's look at a function. This is what expresses a circle. Now how do we take the derivative of this? Well, for one, we could, try to isolate y here as our function. Right? Just pull x over and take the square root to find y. But this is plus or minus, and how are we going to take the derivative of that? Could we take a minus derivative and a plus derivative? Well, we don't really have to. What we can do to take the derivative of this is use implicit differentiation, which is kind of an algebraic method of taking derivatives. Basically, we can take the derivative of one side of the equation and make it equal to the derivative of the other side of the equation. So, dx, the derivative operator of x squared plus y squared, is equal to the derivative with respect to x d dx of 1. And now, what's the derivative with respect to x of 1? As we've learned with constants, it doesn't matter. Let's pretend 1 is a function of x. F of x is equal to 1. There's no slope there. That's just 0. 0 is our slope. Is equal to... Now, we've also learned that if we're taking the derivative of terms that are being added, we can separate them. So this is the derivative with respect to x of x squared plus the derivative with respect to x of y squared. Right? And let's start simplifying. So we already know this one, and we can find it right out of the power rule. 2x plus, how do we find the derivative of y squared with respect to x? Well, we can treat y as a function and the squared as a function and use the chain rule to separate these. So first we pretend y is x and take the derivative of this whole thing with respect to y, which we're pretending is x. So that's 2y, but then we have to multiply that 2y by y with respect to x, the derivative, which is dy dx. This is the derivative we're trying to find, right? Is equal to 0. Now, we can just easily algebraically manipulate this to find the dy dx. We just subtract 2x from both sides and divide by 2y is equal to negative x over y, which is quite interesting. If we know the x point and the y point at any point on our circle, we can find the derivative, which is the rate of change, the slope at any one single point. Or, to visualize, if we have a circle, here's our circle, draw some axes to sit on. If we're thinking of a single point, we can find the slope along the point. This is called the tangent line. It's basically all that derivative taking is about. Finding the slope of the tangent line, which touches only one point. Alright, but that's not all this is good for. There's another example that really stresses how useful this can be. And that is something a little bit odd, where y is equal to the arc cosine of x. Now, first we can make this a little bit easier by saying x is equal to the cosine of y, right? Now, as we may know, the arc cosine of x is basically saying what angle do you take the cosine of to get x, right? So if we take the cosine of that angle, we get this here, right? So this is our angle. If we take the cosine of it, we get this ratio here we're looking at. Alright, so now we take the derivative of both sides, and I'm going to hurry up a little bit. So 1, the derivative of x, is equal to the derivative with respect to x of the cosine of y. By the chain rule, 1 is equal to the negative sine of y times dy dx, our derivative, right? Just like we did last time. And so, dy dx is equal to 1, negative 1, over the sine of y. And this can be simplified a little bit further though, because we have this in terms of y, but we don't want this in terms of y, we want this in terms of x. So, what is sine of y equal to? Just using Pythagorean theorems, the Pythagorean theorem basically, and our trigonometric identities, the sine of y is equal to the square root of 1 minus the cosine squared of y, right? That's, I'll have more videos on that at a later time. So, our derivative of y with respect to x, this marker is running out, I'm going to use another one. Is equal to negative 1 over the square root of 1 minus the cosine squared of y. Now what is a cosine squared of y? Well, the cosine of y is equal to x, so the cosine squared of y, if we square both sides, is equal to x squared. So this is equal to, and this is exciting, 1 over the square root of 1 minus x squared. That is the derivative of the function y is equal to the arc cosine of x. Thank you.